Hi, this is Guru from GuruWrites.com with part 9 of the C# tutorial series, Data Type Conversions and Casts. C# supports two kinds of typed variables, explicitly typed variables and implicitly typed variables. Explicitly typed variables state clearly and in detail to the C# compiler what type of information they expect to store in the variable they declare. For example, byte value equal to 50, the variable byte value is of type byte and stores an initial value of 50. Short value is of type short and stores a value of 1000. In the similar fashion, long value is of type long and stores the number 999,39849 with a L at the end, which is a suffix which represents to the C# compiler that we as developers intend to store a value of literal type long in the long value variable. In the similar fashion, for floating types or single types, we will represent it with the capital letter F at the end, and for a double type, we'll use a capital D at the end to tell the C# compiler what we intend to store. Come, let's look at a similar demo here in our Visual Studio. So launch Visual Studio Development Environment and we'll create a new project here. Click on New Project. In here choose C# as your preferred language, Windows project type, console application, and give it a name. Click on OK. In the Solution Explorer, let's rename our program.cs class by right-clicking and choosing Rename, and rename it to DataType Conversions.cs. I have already written some code to save time. For the explicitly typed variables, copy, and let's paste this in the main method of the class. The first line here represents a declaration and initialization of type byte for the variable byte value to 50. We will display this to the client's console using console.writeLine method of the console class. Similarly, we also have other explicitly typed variables, and if you observe, long, float and double have been suffixed to the right with alphabets L, F and D respectively. Let's hit Ctrl F5 to see what the outcome is. The outcome is as expected. In fact, the L, F and D at the end as suffixes are optional. Come, let's get rid of those. And if you try to hit Ctrl F5 after this modification, your outcome will still be the same as before. So if these suffixes are optional, then why do we write them? You actually do not need to write them. You will understand this when we discuss the second part of the typed variables, that is implicitly typed variables. For now, let's replace those values back again and try to see what is the type of these values using the getType method, which is inherited from the object class. So if you write byte value dot get type, it will show you the type exactly of what it represents within the .NET framework. I will fast forward this video to save time, and we will repeat the same operation for all these explicitly typed variables. Now if you hit Ctrl F5, you can see their type. This is their type to the right that we expected, and they work perfectly fine. If you go and remove the suffixes at the end, they will still show you the same thing. So this is actually what we expected, which proves writing these literals as suffixes at the end doesn't matter as far as explicitly typed variables are concerned. So if I try to change their values from float to double and double to float, this doesn't work. Why this doesn't work you will understand when we discuss typecasts and conversions. On the other hand, implicitly typed variables are represented by the keyword var in C#. The var keyword instructs the C# compiler to infer the type of the variable from the expression on the right hand side of the initialization statement. For example, var long value is equal to some number suffixed with capital L makes the C# compiler understand that we want to store this value as of type long data type. Similarly, for float we represent with a capital F suffix, for double we use capital D, and for decimal we use capital M. M stands for money because the decimal value is usually used to store huge precision currency values. All these suffixes are important. Unlike the explicitly typed variables, you have to specify them. If you do not specify them, the default value understood by the C# compiler is of type integer. As you can see in the last line, I haven't specified any suffix at the end, so the C# compiler will consider 554554 to be of type integer 32 value. Come, let's look at a demo in our same project and the same solution. First of all, let's comment this by using Ctrl E and Ctrl C. This is in Visual Studio 2015. In Visual Studio 2013 and 2010, the command is different. So let's write down varint value is equal to some number. We did not suffix anything at the end, which means it will be of type integer. And now for the long int value, write down some number, but make sure you write capital L at the end. Small l confuses developers who are your friends, colleagues and peers, and it sometimes looks like 1, so avoid writing the small l, though it works too. Write down all the values for float, double and decimal, and then we will see what is to be done. Remember, decimal is represented with a capital M for money. To outcome these results, use console.writeLine, and we will outcome the first result, which is var int value. Since you have not written anything to the right hand side, it will be considered to be of type int32. So to see the type, we write is of type, the method is .getType. Similarly, to outcome this result, we use console.writeLine here, and we have other variables of different kinds. Let's comment them for the time being and hit Ctrl F5 to see the outcome. The outcome is as we expected. The default implicit typed variable is of type int32. Uncomment these values, and now let's explore them as well. So console.writeLine for the long value. And now for the double value, instead of writing the whole console, you can just write CW and press tab. CW is a shortcut for console.writeLine. Now write down the value for double. float, and then finally decimal. Let's now hit Ctrl F5 to see the outcome, and it is as expected. Integer 32, integer 64, double, single and decimal. This only happened because the compiler understood what we want. But if you remove these suffixes from the end, you can also replace the lowercase ones with the uppercase ones, and let's see if it works. It'll perfectly work because this is actually how you should be writing, not in the form of lowercase. And we can see it works fine. So always we recommend you to follow the procedure of using the uppercase ones. In fact, if you go and remove them totally, let's see how your C# compiler behaves now with your implicit typed variables represented by the keyword var. So Ctrl F5, and this time the outcome will be unexpected. You can see if I try to select and mark the values, the second line here is representing something that we did not expect. The long value is being represented as int 32 and not int 64, and the floating value is also wrong. It represents as int 32, which we do not want. The decimal value is not decimal, but it is representing double. So it's all unexpected only because you do not specify implicitly what you wanted. How about if you go for a byte value? A byte is maximum 0 to 255. So if I write 50, I'm expecting this small value to be considered as byte. And if we try to outcome this result, even this will be picked up as by default integer 32, and a lot of space will be wasted for our byte value by our compiler, which is not a good practice. So let's see what is to be done for a byte value. First of all, the outcome, so Control F5. If you look at the last value, it shows you system.int32, and that's a huge chunk of information and a lot of memory wasted for storing a small byte value. So let's write a suffix at the end, maybe capital B for byte. Let's see if this works. This will not work for us. So if we hit Ctrl F5, it throws an error because there is no suffix available in the implicitly typed variables for byte. There is no suffix available even for short. So how do we convert it? We will implicitly typecast it. So I'm sorry, not implicitly, we will explicitly typecast it. So to explicitly typecast, we write byte, and this time it works fine for us. What is the meaning of explicitly typecasting? That we will understand in the next series, continued as conversions and casting. Because C# is a statically typed language, at compile time after a variable is declared, it cannot be declared again or used to store values of another type unless that type is convertible to the variable's type. For example, there is no conversion from an integer to an arbitrary string. If we declare int I and try to initialize I with a string hello world, this will fail in C#. So if you look at the curly underline, and if I hover my mouse, it says cannot implicitly convert type string to integer. If you try to run this application, that will fail too. However, you might sometimes need to copy a value into a variable of another type. These kind of operations are called conversions in C#. C# supports 3 different types of conversions. Let's look at the first one, which is called implicit conversion. When you're converting data types upward, that is, when you are converting from smaller types to higher or upper types, this type of conversion is called implicit. Byte is smaller than short. It is safe to convert. short to int conversion is safe, and so on and so forth. Converting float to double is safe too. Let's look at an example. Int first name is 400, and in double D result we are trying to put first value's value, which is 400. This is considered to be safe. It's like putting an elephant into a dinosaur. It is always safe because the dinosaur is larger and can accommodate the elephant. Implicit conversions are required when the conversion type is safe and no data will be lost. Examples include converting from smaller to larger integral types. These are called implicit conversions. Come, let us look at an example of implicit conversion in C#. So we will initialize first value to 400 and will declare a variable D result and initialize it to the value first value. If I try to outcome the result, it will work perfectly fine. Because the C# compiler will be able to adapt to the value of first value, which is smaller data type, into the higher data type, which is double. It works fine, as you can see. Now let's look at an example of explicit conversion. Explicit conversion is just the opposite of implicit conversion here. So when you're converting downwards, that is when you're converting from a double, which is a big value, to a float, or from a float to long, or from a long to byte. This way you're trying to insert a dinosaur into an elephant, which can be dangerous. You can lose some of your dinosaur. So if you try to write double D value is equal to 99.99 and try to insert that value into an integer, you will get a compile time error if you try to do that. Because here there are chances of you losing some value. But if you really want to say to the compiler that I don't care, even though I lose some value, I'll take the risk. This is how you do the explicit conversion, and this is called casting. So we are casting D value to be casted into an integer type. So 99.99 is being casted into an integer type. You can see you have lost a little value there, .99. So download numeric conversion is explicit and unsafe. Explicit conversions require a cast operator. Casting is required when information might be lost in the conversion process. Might be lost. It is not important that every time you cast you will lose the information, but there are chances you may lose it. And there are chances you will definitely lose it. So explicit conversion is not always safe. Let's take an example of the same. So this was implicit conversion we saw earlier. And now we will see explicit conversion. So we will write double and a variable D result of type some value and also an integer, and we'll try to do what we discussed. Take the double and drop it in integer, and you can see clearly it already signifies an error and says cannot implicitly convert a double, which is a large value, into an integer, which is a small value. So we will typecast this using explicit conversion into a type of the left hand side, which is integer in our case right now. And if you try to outcome the result of first value, now it will work, but you will definitely lose some precision value. As you can see, this is the whole value. You won't receive everything, you will lose something. So you can see you have lost something there. You only got some value which is before the precision. So guys, this was explicit conversion, and which always requires a cast, and it is unsafe. You lose some data. So I hope it is clear to you what is implicit and what is explicit conversion. We have a third kind of a conversion as well. It's called conversion with the help of helper classes. Why would we need this? Let's take an example. So suppose to convert between non-compatible types such as integers and strings, we use these conversion methods. The first one is convert class from the system namespace. So if I ask the end user to input a number using console.writeLine and try to grab that result into a number type, here console.readLine will always outcome a string, as you can see, and the string is not able to convert into an integer. Even if I try to explicitly typecast this into a type integer, it will not work because it is not supported by the .NET framework. So what do we do in this case? In this scenario, we use the helper class, which is system.convertClass, and the convert class has a method. We will use that method, but before that, let's write down console.readLine, and we can see this doesn't work because we haven't used the method. The method is dot after the convert class to int 32 or to int char or to int double. It supports all the methods for all the built-in data types. You'll have to choose one that you want to convert it to. Right now we want to convert this to be of type number, and number is of type integer 32. So I've chosen convert.int32, and this should work fine for us now. So if you outcome the result, and to hit that, hit Ctrl F5, write some number, and it works perfectly fine for us. But if I try to run this with Ctrl F5 and try to insert a number which is a string of type this, we will get a input string is not in the correct format exception, because we are unable to convert using convert.2832 the value of string 777HHJJJJ to the number type. Doesn't work for us. So we will use in this scenario exception handling, but we haven't learned what exception handling is, so I leave this topic for the future. How about the second way of using the helper class? We can use the parse method of your built-in data types. Let's use the parse method this time for the previous example. So let's copy and paste. Uncomment with Ctrl E and Ctrl U. In older versions of Visual Studio, you can use Ctrl K and Ctrl U. So now you can see here we have this instance which we can remove and replace it with int32.parse method. So the parse method will convert the value to be supported on the left hand side. You can use different supported values. I'm using integer because we have integer to the left hand side. Let's see if this works. This works perfectly fine. So instead of using convert class, you can also use this parse method, which is supported by almost every value. Now this once again fails because we wrote hello there and it is not able to convert it. So you have to use exception handling. Like I said, exception handling will come in the later on series somewhere down the lane. So right now we'll just comment this and leave it for the while. Out of all these two values, I prefer none of them, but I prefer the third one, which is the TryParse method. What this method does is it tries to convert. If it is unable to convert, it returns a Boolean value, and using the Boolean value before our application crashes, we can handle the error. So for example, if I use TryParse method with int32 structure, let's see how it works. We will declare an output variable by the name out num. In this we'll be outputting the result, as you will see in the next line. The outcome is always a Boolean value for true and false, so we will catch that and grab it in the result variable of type Boolean. So bool result is equal to int32.tryParse. Try to parse the value which is in console.readLine. ReadLine will give you a string value, comma out keyword will grab this and throw this message into the out number which we have declared at the top. So whatever outcome comes from console.readLine, we will output that number into out num, which is of type integer. If this is successful, result will show you true, else result will show you false. So let's use an if statement and try to compare result. If result is equal to true, then it was successful. So output a message saying operation or conversion was successful, and since it was successful, you can also output the message of whatever value was returned in outNum variable. So we will just copy outNum and paste it over here to see what the outcome is. Else, if the operation, the TryParse operation fails, TryParse will return a false value. We can say conversion has failed. It's as simple as that. So this way you can handle errors rather than crashing your application, and that is why compared to the convert class and the parse method, I appreciate TryParse more. Let's write down some number, hit enter. It works fine and it says conversion was successful. Amazing. Let's run once again and try to this time fail the application. This time it failed, but it did not crash the application. That is superb. This is one of the most important reasons why I like the TryParse method. In fact, in the if statement, there was no reason for us to write is equal to true, because that anyway returns a boolean value. So once again, if you check, it works fine. So you may omit writing result equal to true. You can just write result. So once again, for a recap, TryParse method is used to convert string types to other .NET structure types like integer, float, double, etc. Parse method throws an exception if it cannot parse the value, whereas TryParse method returns a boolean value of true for successful conversion and false for a failed one. In a nutshell, use parse if you are sure the value will be valid, otherwise use TryParse. Thanks for your valuable time. If you feel you have learned something new today, please click on the like button below. If you have any queries or suggestions, kindly post them down in the comment section below.